All right, welcome back. Week 4, Chapter 5, Database Processing. Did you know you used a database to register for this class? When you went into MyFrancis to register for a new semester, you used your student ID, which is attached to your login. That pulls up a record of all the classes you have taken, classes you need for your major, and then bounces that off classes that are available to be enrolled, along with how many seats do we have in those classes, who's the instructor, where are meeting times. All of this is a database, and there is a lot of gears going in the background that you necessarily don't get to see. So what's the purpose of a database? Well, a database is simply something we use to organize and keep track of things. This could be clothing for a store. This could be student records for St. Francis. It could be books for a library. And we get a couple general rules. If it's a single theme, it could be stored in a spreadsheet. If it's multiple themes, we need to use a database. But what's a theme? Well, a single theme would be perfect. Student grades. Look at this example. We have their name, student number, homework assignments, and the grade they did for it. Perfect. We don't need anything else to add to this. This is what we would need just for their grades. But if we wanted to throw other layers onto this, maybe we want to reference emails or office visits, we need to have a database to link everything together. What's the best way to link all this information together? We need a unique marker. We can't use names. We can have two Tom Smiths. The student number is our unique link between every one of these. Our first table is our email table. We see student 1325 sent 2 emails. Well, who is that? We go to our second table. Hey, that's Andrea. There's some more useful information about her from there. The third table is office visits. So we have 3 different unique tables here that can all be queried together to output all this information. How do we do that? We do it through a database management system, sometimes called DBMS. This is a program that is solely used to create, process, and administer a database. All your big software companies make them: IBM, Microsoft, Oracle, and there's also open source options out there. MySQL is great. It's free for most uses, and for a lot of times it is a very good replacement for buying a license for SQL Server or anything else. You might even have Microsoft Access on your computer right now, depending on which version of Microsoft Office you bought. Access is incredibly powerful and it's great for smaller databases. But once you reach some of its limits, then you really need to go to a more industry level database like SQL Server or DB2. Every database uses 4 basic functions. We need to read, modify, insert, and delete data. And it's kind of common sense when you think about it. If we go back to, the St. Francis student database, we get new students sometimes every semester. We need to insert those. We need to remove students who have graduated. We need to modify information about that student. Maybe they changed majors, and it could be as simple as inputting grades. And obviously, all this needs to be able to be read. We need to have, we need to put search queries, and we need to have all that information be out processed for instructors and faculty. Most of your databases use SQL, SQL. You'll hear it pronounced both. It's structured query language. This is an international standard. There's an ISO requirement that governs how SQL databases are written and how they're administered. Down below, you see an example for it. Hey, if we want to insert a student, here's student number, student name, their homework assignments and grades, and the last line shows what that value would be, what it would be output. There's the student number, he's number 1000, his name's Ben Franklin, and those are the grades that he received for each homework assignment. When we're making a new database or if we're administering an existing one, we really need to make sure we set up security. You know, how are users accessing it? What accounts do they have? What is our password convention going to be? What permissions do we have? And this is incredibly important. If we think about the university's database again, you know, all your information is linked by your user ID number. But as an instructor, there's certain things that I don't have any business accessing. I don't need to know about financing or, you know, different scholarships you have. I just need to know about your grades and the classes you're in. All that other information, that's for the finance department. They need to deal with that. So we need to really have very clear boxes, if you will, of what information each user will access based on what type of user that is. Are they an instructor? Are they an administrator? Maybe, maybe your dean of the School of Business has more access than your average teacher. Obviously, finance has access to things that the dean wouldn't. So we need to be very clear on these, and we need to make sure that as the database is continually used and we grow and we change hands, we still maintain our clear user permission. So how do database applications make databases more useful? Well, there's different elements for this database information. We have forms that we can view the data, insert. This is where we make all of our updates from. We need to search for information. We need to have reports. And there's different application programs we can use to, maybe there's special circumstances we need to do. This is a perfect example. There's an out of stock situation. If we have a database for a store and we sell all of the pants, well, maybe that can automatically generate emails to let purchasing know, hey, we're out of pants, out of this size, out of this type of pants, go order more. So we can have certain automatic things built into the database based on certain functions as they happen. So here's an example of a report. This is for a student report, but you can imagine this could be for anything else. It's great. We have the student name, we have their number, homework assignments with grades, email, the date the email was sent, and what the message was. Database software also gives really powerful search functions too. Let's say I remember I had a conversation with a student who was talking something about barriers to entry, but I really don't remember what the whole conversation was. I could pull up my search function, I could search the word that I know or the phrase that I know, hit search, and it'll pop it out in the bottom. Hey, Andrea, on the 13th, she had a question about using IS for raising barriers to entry. If we didn't have a DBMS with a search function, I would have to manually go through all of our records to find this conversation. So how is data model transformed into database design? Well, it's through normalization, converting poorly structured tables into two or more well-structured tables. What's our goal? We need to construct tables with a single theme or entity. This minimizes data integrity problems. Data integrity is so important for a good functional database. Anytime we have data duplication, we run into issues. If users lose confidence in a database, they will stop using that database. We need to make sure the information in a database is secure, it's accurate, and it's easy to use. The end user has the ultimate say in how effective a database is. If you're ever in the position to administer a database, be a part of a database team, you really need to look for active feedback from all of our users. Be receptive to it and look for ways that we can make that database better. All right, this concludes chapter 5. Please move on to chapter 6. Work on your homework. If you have any questions, let me know.